Greetings, fellow people. It's Kevin. I'm back to talk to you more about logarithms. Hope you did okay with the last lesson. We had a common logarithm with the base of 10. Today we're going to talk about something called a natural logarithm. Now, the natural logarithm is based upon a number that you may or may not know. The number is e. The number is approximately 2.71. Now, here's the interesting thing about e. It's like pi, where it's irrational, and it has no repeating terms. There's no pattern to it. But why do we call it a natural logarithm? Well, just like pi is a number that happens in nature, because pi is the ratio of a circumference of a circle to its diameter. No matter how big the circle is, the ratio is always pi, 3.14, and so on. But pi is also developed in different ways as well, that as you grow in your mathematical knowledge, you'll know different ways that pi can be calculated. The same with e. E is not based on our number system. It says that we didn't make it up. We made up base 10. We count by tens because we made it up. But within that system, this number appears as a result of a natural calculation. Now, I'm making another video. If you're interested in where that comes from, I'm going to go into more detail about it. But for now, we're going to basically assume this. A log with a base of e is now going to be rewritten as natural log. Now, just so you guys know, I always make a cursive L when I do natural log. It's just a habit, so it doesn't look like 1n or something. That's just my personal preference, so just so you know. So I just kind of told you that. What is a natural log? A natural log is a log that has a base of e. Okay? So since we're going to now call this the natural log, then what's its inverse? So if I say that the log base e of x equals some number y, and I rewrote this, then this means e to the y equals x. Right, now you do not have to know that e is approximately 2.71. You can, just like you have to kind of know pi is 3.14. But on your calculators, you will notice, just like you had log logs, you have ln's. There, there, there. ln stands for natural log. Again, natural log. Why am I putting the L first? If it's natural log, shouldn't it be NL? It comes from the French log de naturel. So we call it ln. And if you notice in many of your calculators on your 84, notice right above natural log, it's hard to see on here, but you have e to the x. You can't see it on here. You can see it here as e. Now you can't see it on this calculator, but this calculator, if I hit the second button, then this ln changes to an e to the x. So they're related, e's and natural logs. The natural log is the base of e. You don't have to really know much of that to do these problems correctly. All you got to do is remember that ln of 50 is really the same as this. So if I was just going to rewrite it, it'd be 50 equals e to the x. Remember, that's your base. That just jumps over here. Or you can write it this way first if you prefer. Okay? That's the equivalent statement. We don't have to solve it. That's just the equivalent statement. Here. Now you don't have to rewrite this every time. I'm just showing you. So your base is e. It jumps over here. 36 equals e to the 2x. Or, again, doesn't matter which way you write it. Now there's a little trick that I do. And I don't know why I do. I think I learned a long time ago. I kind of taught myself when I was in school, because I didn't always remember this change, this formula, this rewriting. So here's what I did. I know an e and natural logs are different. So I'm going to what I call e both sides of the equation. So e to the natural log cancels out. You're left with 6, which is approximately e to the 1.7918. So I don't know if you like that or not. I just find that kind of fascinating, and it's like a little trick that makes things a little faster for me. Now on this page, we're going to convert them back a different way and write them as logarithms. So the same formula that you know, that's log base e, okay, of 8 equals x. But we're going to write that as natural log of 8 equals x. And that's how we change it. Okay. Same thing as before, except we don't write log, we write ln. Now, here's my trick, and I don't know if you want to do it this way, but here's what I like to do. How do I undo an e? I take the natural log of both sides. Because these cancel out, I'm left with 5. And that's what I got. That's how my brain interprets it. It's much easier for me that way. But I want you to know they work both ways. Okay? Alright, so I'm going to show you here. If I take the natural log of both sides, and I'm using natural logs because they're the inverses of e. Natural logs and e cancel out. Now why does this 2 remain? And why does it become a whole number? If you remember our properties of logarithms, the 2 can drop in front because it's a power. So it really means 2 times the natural log of e equals the natural log of x plus 1. And what's the natural log of e? It's 1. So just remember, e's and natural logs are inverses. The same way that 10 to the x is an inverse of log, because log has a base of 10 unless we define it otherwise. All right, let's solve some equations. If you follow that little thing I told you, it's really easy. What's the inverse of an e? Natural log. Take the natural log of both sides. These are left, or I'm sorry, these cancel. I'm left with x is less than the natural log of 9. Now, you got to do your calculator. To get the 4 decimal places, you got to type that thing in the calculator. Just type natural log of 9, and what you get is 2.1972. That's how we solve the equations. Let's just keep rolling through. Do the natural log of both sides. These cancel. The natural log of 31. So x would equal the negative natural log of 31, which when we put that on the calculator, we get the answer of negative 3.4340. My point didn't show up, but there it is. All right, there you go. Now before I take the natural log of both sides, careful, this is my tricky part. I gotta get the e by itself. Okay, I got stuff with the e. So I'm going to solve it like a regular old equation. Well, aren't they all regular old equations? Just have different stuff in them sometimes. 1 plus 3 is 4. Divide both sides by 2. E to the x equals 2. Alright. I'm going to put that up here again. What's the inverse of e? What undoes an e function? A natural log function. X equals natural log of 2. Punch it into the old calculator and you will get 0.6931. Subtract 1 from both sides. Leaves us with 5. E to the x is greater than or equal to 6. Divide both sides by 5. I get e to the x is greater than or equal to 6/5. So I'm going to take the natural log of both sides. The natural log of 6/5. Alright, just that step there. Well, natural log of e becomes 1. Plug natural log of 6/5 into the calculator, and you get 0.1823. Bingo. All right, what do you think? E to the negative 4x equals 5. Well, an inverse of e is natural log. Gone. Negative 4x equals natural log of 5. Got to divide this by negative 4. So x is going to equal negative 0.4024. All right. Another one. Subtract 7 from both sides. Gives me 2e to the negative 3x greater than or equal to, what's that, 8? Remember, I've got to isolate the e, get the e by itself. So divide by 2. Alright, let's put that up here. So e to the negative 3x is greater than or equal to 4. Now the e is isolated, so I'm going to take the natural log of both sides. Kind of out of room, so I'll just write it down here. Natural log of 4. So that's gone. I have negative 3x greater than or equal to natural log of 4. Divide by negative 3. And just like all the normal rules, if you divide or multiply by a negative number, you flip the sign. And natural log of 4 divided by negative 3 is 0.4621. And I almost forgot my negative. All right, negative 0.4621. Let me make that a little bit nicer. Let's see it better. Negative 0.4621. Okay. All right, we're going to stop this video right now. Give you guys a little break, get a little rest, think this through. Or if you're ready to go, just open up the next video, and we'll be done with Section 7, Chapter 7. See you guys in a little bit. Have a good one. Bye.